we talked about the operators. You do have to install the package, and you do have to load it, and I can't remember if I've done that yet. I haven't. Okay, so I've loaded it. So here's our model. And models usually, I write them like this, but when you look in the books, they're usually written like this to make them unambiguous, where the tick, the preceding tick or apostrophe that marks the beginning of the model and the one at the end are on separate lines. The model is just a text variable. That's all it is in R. So if you look down here, you can see it. And it's telling you there's a line there, that \n is special character, which means throw a line. And we're using only one operator because it's a CFA, the is manifested by operator or is defined by operator. So these are the measurement items for this latent variable and these for this one and so forth. And that's all we're having it estimate. Now, because unless you know the scale, unless you know that the scales for these are 3 different tests. People responded to test questions measuring their visual cognitive ability, their textual cognitive ability, and not sure what speed is, speed of perception, I guess. If you know that they're all measured on the same scale, you don't have to worry about fixing the scale that much. But assuming you don't, in order for there to be some sort of contrived set scale, you have to either fix one of the loadings to be 1, or an alternative approach is to fix the variance of the latent variables to be 1. That forces all of the measurement items to be more or less on the same scale. Otherwise, you can't interpret it. So the default with the CFA is to fix the loading of the first, is to fix the first loading to 1. Okay, so also with a CFA, because all of the latent variables in a CFA are exogenous. They're not predicted by other latent variables. So they're all considered that they're all exogenous because they're not predicted. And it will automatically, it assumes and measures that the correlation or the covariance among the exogenous variables. So in this model, it automatically estimates the double-headed arrows mean covariance. So it's estimating 3 sets of covariances, all sets of possible pairs in the CFA. And so we use the CFA function, and let's take a look at it. I don't believe well, actually, I provide that to you. If you go into your folder under documentation, you'll see this. So I printed it out and made it pretty, and let's take a look here for that correction to chi-squared. I hate it when it does this. Okay, pull that down and over so I can get at the bar. And so here's the actual function. And this is from the help screen. So here are all the arguments. These are things that you can do. These are parameters that you can adjust and estimate. And of course, in the documentation, this came right out of R from the help screens. It defines each argument quite well, concisely, and yet with enough information to answer questions if we had time to go through it. So if the correction is in there, it would be in here somewhere. I'm not sure what to look for, but the other point I wanted to make, note that this is very complex. Also, really, the CFA function as well as the SEM function, SEM function in lavaan, they're just simply wrappers to the actual lavaan function. What they do is they just call the lavaan function, but they're kind of a stripped down version of it. So again, as I look through this, I do not see where that correction might be, but if you took a little more time, you would probably find it. It's pretty complex. There's a lot of control that you have. Those arguments represent control that you can exert on the way it fits, it estimates. So we do that, and it puts the fitted object here in fit 1, and then we look at the summary. So let's take a look. This is just our basic, most simple execution. We have the model and we have the data. So let's look at the summary. What you get if you don't do anything different than that, and what you get is you get the overall fit, of course, but you don't get any of the other fit measures. You get the overall fit, and this one's not very good. It's not acceptable. There's another whole block of fit measures that you can evoke or call by using the argument fit measures equals true. And then we get estimates for our parameters. Note that the first loading in each block is set to 1. That's the default. And here are the covariances among the latent variables. And then we get the residual variances for each of the predicted measurement items, as well as the residual variance for the 3 latent variables as well. And you can see the second one, x2, has quite a wide residual variance. Residual variance is a measure of the error, how big the spread of the error is. And you want them to be small. It's better if they're smaller. So this one might be a problem, but so that's all you get with the basic information. And again, note summary is a method. It works just about with any single linear model. The output that is created is defined by the author of the package and the function. They can make it show anything they want. So here, what we're going to do now is just estimate it again, but instead of fixing the first factor loading to 1, we're going to fix the variance of each latent construct to be 1. And you do that using this is the covariance operator. It's variance if it's the same variable on each side of this double tilde. If they're 2 different variables, then it's the covariance. But what we're doing is we're using this pre-multiplication mechanism to set the value to 1. This means set the value of the variance of visual to 1. And this is an alternative way of setting the scale so that you can get, so that your parameter, you'll be able to interpret your parameter estimates from a CFA. So we load that, and this should actually say model 2. And note here, now we're saying standard LV. This will provide both unstandardized and standardized estimates for the latent variables. And here we're saying fit measures equals true to get the range of fit measures out of the summary. So here we fit it. This first function here fits it. And then this gives us the results. I like to see standardized estimates. It's easier for me to understand what they mean. But so we go up here. Note the overall fit's unchanged. All you're doing is changing the way the information is presented and what sort of information is presented. So there's the overall fit. It's unchanged, and now we get the range of other fit measures. Here are these are the comparative fit measures here. And they're not very high. they're not high. They should be above 0.95. And then this doesn't mean anything by itself, but these numbers are quite large actually. So again, that's indicative of it not being a good fitting model, and the root mean squared error and the standardized root mean square residual also not low enough. Note that all those fit measures, the absolute and the incremental as well as the overall, are poor, but all of the parameters are significant, are highly significant. So those two dimensions of your fitted model are really separate. You do need to have a good overall fit before you can even interpret anything. So even though this looks like the model fits well, the overall fit was poor, so we would not rely on these. This z-value, this is the WALD W-A-L-D statistic. All it is, it's the point estimate. These are the point estimates divided by the standard error. And you want this number to be large. You want it to be 2 or more, and they're all very large, or -2 or less. Okay, so we have that. Generally, a CFA precedes fitting a full model because you want to guarantee, you want some assurance that the measurement model is good before you fit the entire model. So note that the output, there are 3 sections. The first section, which is just the first 6 lines, show you how many observations, show you how many iterations for the fitting function. It minimizes the residual covariance for it to converge. Converging just means it reaches a point where it's changing the weights that they just don't change much anymore. The numbers don't change, so you just stop. And there's some tolerance level where when the change is below this tolerance level, you just quit. It's possible, if this is a converging algorithm, it's possible for it to go in the wrong direction and never reach a solution. Okay, and then so you have the first 6 lines are the overall fit. Then you get these absolute and comparative fit measures that extend all the way down to here, and then these are the estimates of the actual parameters that you're fitting, that you're estimating.